Hello, this is Farhan Shakil from the Republic 2.0, and in this video, we'll be talking about the second phenomenon of the superposition, and that is known as interference. In the last video, we talked about the stationary waves, and stationary waves are created whenever two waves having the same frequency are traveling in the opposite direction. Now we have got the second phenomenon of superposition, and that is known as interference. So first of all, how would you define interference? It is such a phenomenon, whenever you're talking about interference, it is such a phenomenon when two waves having same frequency and traveling in the same direction, traveling in the same direction. Superpose, whenever such two waves superpose, the phenomenon is called interference. On the basis of superposition, interference is basically of two types. And what are those two types? Interference can either be the constructive interference, and constructive interference happen when a knot falls over a knot, or an anti-knot falls over an anti-knot, or a crest falls over a crest, or a trough falls over a trough. Such type of interference is known as constructive interference, in which the amplitude is built up, right? For example, if the amplitude of one wave is 1 meters and the amplitude of other wave is 1 meter, the resultant amplitude has to be 2 meters. Secondly, you have got destructive interference. Remember that destructive interference happens whenever a crest falls over a trough, or a trough falls onto a crest, or a knot onto an anti-knot, or an anti-knot onto a knot. And in case of destructive interference, it leads to the cancellation of the amplitude, meaning thereby, if one wave is going to have an amplitude of 1 meter and the other wave is going to have an amplitude of 1 meter as well, as a result of destructive interference, the resultant amplitude is going to be 0. So that is how we need to know about the destructive interferences and the constructive interferences. In constructive interferences, the amplitude is added up, and in the destructive interference, the amplitude is cancelled out, right? So now, remember, in this topic, we'll be talking about two examples of interference, and that is the interference of the sound waves. And secondly, we've got the interference due to the light wave, only to understand that why interference happens. So first of all, let's talk about the interference of the sound waves. How do the sound waves interfere? Interference of sound wave. And how I would talk about this example. For example, you've got a same audio generator that is connected to some sort of an electric supply. This is an electric supply. This is an audio generator. And to this audio generator, we have connected two speakers, right? Let this speaker be S1 and let this speaker be S2. Now, everybody knows that whenever sound waves are being emitted, the sound waves are being emitted in the form of compressions and rarefactions. So first of all, this solid line is a compression, and then this dotted line is a rarefaction. Then a compression, and then a rarefaction. Then a compression, and then again a rarefaction, right? The same thing going to happen with the S2 as well. We've got S2 loudspeaker. First of all, we should be having a compression. Then I should be having a rarefaction. Then a compression. Again a rarefaction. Again a compression. So that is how waves would kept on flowing. Now you can see that on this path, we have got this point where the two waves interacted. We have got this point where the two waves interacted. We have got this wave where the two waves interacted. We have got this point where the two waves interacted. We have got this point where the two waves interacted. So all these points would have some sort of interference, right? And it is yet to conclude that whether this interference would be constructive one or would be destructive one. But by the definition I told you earlier on, remember that when this rarefaction is intercepting this compression part, there should be a destructive interference. When this compression is intersecting with this compression, there should be a constructive interference. Now we need to talk about the conditions that when the constructive interference is happening and when the destructive interference is happening. So first of all, if you look into this thingy, you can easily see that this is half of wavelength, right? This is lambda by 2, and this is the distance between two consecutive compressions is lambda. So at this point, the waves from S2 has covered a path of lambda, and the waves from S1 has covered a path of lambda by 2. So at this point A, the path difference, at this point A, the path difference has to be lambda minus lambda by 2, meaning thereby we've got lambda by 2. Now let's talk about the path difference at this point. This one, the point number B. You can see that this wave has covered almost one wavelength, and you can see that this wavelength has covered almost 1.5 wavelength. So the path difference at this point would eventually be 1.5 wavelength minus half wavelength, and that would eventually be, for example, one wavelength, and you'll eventually be having lambda by 2 wavelength, right? So that is how you must be talking about these points. Okay. Now, if you talk about this point, you can easily see that this wave has covered almost a path of, for example, you're talking about this point. This wave has almost covered one wavelength, and the waves from S2 has covered almost two wavelengths. So what would be the path difference at this point? You've got 2 lambda minus lambda, and it comes out to be lambda. So that is how you talk about the path differences of these waves. So we just got to know that interference is of two types. Interference is of two types. One of them is the constructive interference, and the second one is the destructive interference. So we have got constructive interference, and then we have got the destructive interference. So in the case of constructive interference, we just got to know that the path difference would always be an integral multiple of wavelength. And whenever the constructive interference is happening, we would be having a maxima. Maxima is a point of a loud sound node in the case of interference of the sound waves. And whenever there is destructive interference happening, the path difference would be the integral multiple of wavelength, right? And that would eventually result into a minima. So that is how interference happen. We've got the constructive interference, we've got the destructive interference, and in the case of, for example, if we would have been talking about the light waves, it would have been the same thing. But in case of a constructive interference, light waves would always give you a bright spot. That is just common sense. And destructive interference would always give you a dark spot, where the amplitude of the resultant wave is going to be 0. So these are the things that you need to know about the interference. Now, in the next video, I'll get back to you guys with the third phenomenon of superposition and how it is different from the stationary waves and the interference, and that is going to be the diffraction. Thank you very much.